Hello everyone, welcome to Indian School of Physics. So guys, I gave this problem yesterday and I received many solutions, more than 40 plus solutions I received, and some of them were correct, and most of the people have made mistake despite two tutorials on the same concept. So we will just discuss this question very quickly. So this was the question given. I know, and I think most of you have gone through the last video where this question was given. So I'll directly discuss the problem itself. So here is the solution part. Since this bead Q is moving on this rod, and this is connected to a massless string, and there is a massless particle which is moving on this another rod which is making angle of alpha, and it is moving with constant velocity of v naught. Alright, so the very first thing we are going to write the constraint relation. Here I can say this angle is going to be beta minus alpha, because this angle is exterior angle beta and this is alpha, so pi minus beta, and this will become beta minus alpha. Alright, sum of these two is beta basically. So here I can equate the velocity component along the length of the string. So v naught cos of beta minus alpha is going to be v1 cos beta. This is first equation which we are going to use, and we are getting it through constraint. I think nearly everyone has made the right equation for this. Now we are going to observe point P with respect to we are going to observe point Q with respect to P, and its motion is going to be circular in this situation. So let's analyze this. Since it is moving with constant velocity, we don't have to worry about pseudo forces. Here I have resolved the velocity v naught into two components perpendicular to this rod and along the length of this rod. Resultant is along this rod, so along the length. Here we are resolving two components. One is v naught sine beta minus alpha, and one is v naught beta minus alpha. So now if you look at this part, I am observing from here, and this velocity v relative, because along the length of the string it is going to be 0, so no need to consider this. And here we can see earlier this was v1 and its component is v1 sine beta, and here this was having velocity v naught sine beta minus alpha. So we will reverse it and we will get to this. So v relative with respect to this point, we are going to get v1 sine beta minus v naught sine beta minus alpha. Now here if I substitute the value from previous equation using constraint and substitute in this relation here value of v1, I'll take v naught common, and this will become sine beta and cos of beta minus alpha by cos beta minus sine of beta minus alpha. I'll bring it this side, and it is sine a cos b minus cos b sine a. So sine of a minus b result we can use. So it will become sine of beta minus alpha. So this will become sine alpha in the numerator after simplifying, and we are getting such a nice value of Vr, which is v naught sine alpha by cos beta. After this I can write force equation. So net force towards the center is going to be T minus n sine theta. Gravity we don't have to consider because it is g into the plane. So it will be T minus n sine beta. So T minus n sine beta is equal to mv relative square by L, mass into acceleration we are writing in the relative frame. Now I can substitute the value of Vr. And by the way, from ground frame, if you see, the net acceleration must be in this direction because of cos beta component of T, and in the vertical forces are balanced in with respect to ground frame. So n is equal to T sine beta, and acceleration of this bead will become T cos beta by m. So now this value I am substituting here, eliminating m, and I am getting T minus T sine beta m times v relative square, and this is 1 minus sine square beta cos square beta. Bring it in the denominator, and we are going to get this T as mv naught square by L sine square alpha by cos to the power 4 beta. And here I can write A is equal to T cos beta, which is going to give me v naught square sine square alpha by L cos cube beta, and this is going to be the final answer for this problem. Now see, the kind of mistake students have done is The possible mistake number one, which I have observed in their solution, one is in the frame of P, student may calculate only VR square by L. Many people have written this itself as the net acceleration, but there is a catch, because in the frame of P, the component of n will also come along the tangent, and which is going to provide necessary centripetal as well as tangential acceleration. So this will be, it will give component of normal reaction along the tangent, so there is tangential acceleration. And this is one part where students have made mistake. They wrote the radial acceleration properly but forgot to include a tangential. Another possible mistake student may do if they don't resolve velocity components properly in the frame of P and take wrong direction of relative velocity. So another possible mistake which I came to know from the students, they could not resolve this properly. They could not resolve this properly. So this is one method which another possibility where students have made mistake. So just guys, hopefully you'll take care of this next time onwards. And guys, this is related to compete from Unacademy. It's a fantastic way of learning chemistry, physics and maths, and you can compete against your friends and other peers. And so randomly you'll be getting 5 questions of PCM, and whoever solve most number of questions, they will be getting they will be the winner, and based on that some rating will come. So if you beat some high rating student and you are less rating, you will be awarded with more rating points, and it will be a prestigious thing, and there will be a lot of prizes also in this. So it's a fantastic way of learning, so just give it a try. So that's it in this video guys. I hope you have enjoyed this, and if you are liking these videos, please make sure that you are subscribing to the channel and you are sharing it with others, and it will be helpful for me. And yes, so I'm looking forward for it, that you will be sharing this channel and these videos with many more people. Thank you.